Okay. So yesterday we have completed the transformations, right? I did not discuss all the transformations here. The mostly used ones I discussed here. Okay, so those are enough actually. You don't need to discuss much about the other ones. Okay, so let's get on to the actions part now. Okay, there are like several actions case actually here. We are going to use some of the actions even in the data frames as well. Not all, some of the actions as well. The best example and very frequently used one is actually collector. And I told you, right? First also we use. Okay, except these two, others we don't use much, but still we'll discuss. Okay, the important ones we'll discuss here. So collect I've already discussed, right? Let's say I'm just trying to create actually an RDD like this. Yesterday we have created, right, some RDD. Yeah, let's say I'm just trying to create RDD like this. So what collect will do is collect actually will take the data. Collect actually take the data from the RDD. Collect actually takes the data from all the partitions, I can say, after like transformations are performed. So that means who is going to run this collect command? Master node is going to collect the data. So master node is going to execute this command actually, correct command. Okay. So all the partitions data will come to master node. So never ever do collect action or never ever apply that collect operation or action on top of huge volume of data. Okay. If you do that one, your system will hang actually because generally master nodes, right, will specify like let's say 32 GB or 64 GB of RAM or like 32 cores or 64 cores like that, right? See, if you want to process huge volume of data with a single system, it's very difficult actually. So that is the reason why never ever use the collect operation or collect action on top of huge volume of data. Okay, so we use it regularly only on small data set, not on the huge data set. Okay, so there is a specific reason why we use collect actually in real time in data frames as well. Collect actually gives the output in a list format. Okay, that is the reason why we use it actually. If you are expecting output in a list format, we mostly use this collect only. Anyway, I'm going to discuss that one in the data frames. For now, here you just understand that collect is an action. The moment you like Spark sees the collect command, right? So it will start executing the commands, the DAG flow. DAG flow in the sense like RDD1 onwards, it will start execution. Okay, that is what we understood already. Okay, next one is reduce anyway I'll discuss. Aggregate also I'll discuss. Fold also I'll discuss. So let me discuss about the first. Okay, this one also we use it regularly. Instead of collect, what I will do is I'll just mention here first. Zip with index means like what it does. A comma 0, B comma 1, C comma 2, D comma 3, E comma 4, like that it will display, right? So from that, it will try to take only the first element. That's it. Okay, let me execute this one. Name error. Okay, I think I did not create the session here. Let me go and execute this. Spark session we need to enable. That is the reason why it is throwing error. That's okay. Now let me execute it once again. Now see, it will take only a comma 0 element. So it will not display other elements here. First element it will take, that's it. From the first partition. See, it has given the output as a comma 0. Okay. So next one is, any questions on this one? No, nothing, right? If you want to see the documentation for that one, you can go and check that one quickly. Where is that? Yeah, okay, let me search it here. Control F. First, yeah, this is the one. What it does is, so returns the first element of this RDD, in this RDD. Okay, that is what I told you. Okay, so, okay, yeah, fine with that one. Nothing to discuss about that. Next, take. Take is also something related to taking the elements from the RDD. Now let me try to use that here. Where is this? Yeah, this is the one. Instead of first, I'll just take, but take actually takes the number as an input. Okay, so let me go and check the documentation here. So Control F, take. Okay, this is the one actually. If I click on this one, takes the first number of elements of the RDD. So you need to provide the number here so that it takes that many number of records from the RDD, that many number of elements from the RDD, I can say. Okay, so for that, what I will do is take of 3 I'm taking here. Okay, or take of 4. See, if at all, if you want to see the output, sample output, if at all, if you want to see, right, the take is the best option, I can say here. Don't use the collect always. Collect will take the data from all the partitions. Collect will give everything. But take will take only the number of elements that you're specifying. See, since I mentioned 3 here, it is taking actually A, B, C elements only, not all the other elements from the RDD. Did you get my point?
Sure.
Okay. So for each is just for iteration. Top also I'll discuss here. Top is also similar to that one only. But the difference between this one is it will try to order the data. Where is that one? Yeah, top, right? So top element. So what is your expectation here? Take means it is taking the data from like first 3 elements, right? Top means it will try to sort the data in an ascending order. From there, top elements it will try to pick it. Okay, let me try to execute this one and see the output. Based on the output, actually, we'll give a conclusion here. See here, E4, D3, C2. What is this actually? In the case of take, actually, we got ABC. Now, in the case of this one, top, we are getting EDC. Top element means last elements it is trying to pick up. That's it. That is the difference. Okay, you can use either this one or this one. Anything is okay. But take is the best one out of collect and top. Because you see, in order to find out the top elements, right, it has to again sort the elements, right? It's a little bit costly operation. Okay. Now anyway, moving on. Anyway, we don't use all these things much actually. I'm just for understanding purpose, just for knowledge purpose. I'm just trying to discuss all these things. Okay. So I can take the count as well here. So if at all, if you want to see how many number of elements are there in the RDD, you can happily use that. Actually, count is also an action. Okay, let me count will not take any input here. Count will not take any parameters. Let me take count here. See how what you're getting. How many elements are there? 5 elements are there. See 5 output we got here. Just number of output, that's it. Number of elements in the RDD, that's it. So similar to that one, we have min, max, sum also, right? Okay, let me try to take that one as well. Min, I'm taking, sorry, my bad guys, 1 second. So min of that RDD. See what you're getting here. The minimum element will be displayed here. See a comma 0. So max also I'm taking here. Okay, and let's see what is that it is printing. E comma 4 we are getting. Okay. So instead of these things, actually, I'll just try to take the numbers here. Let's say 20, comma, 10, 15, comma, let's say, sorry, 12, comma, 17, comma, 84, comma, something like that I'm trying to take here. Okay. So zip with index, I'll just try to remove from here and I'll just try to take the RDD2 dot max I'm taking here and see it is going to display actually the max value from it. Okay. So why I'm taking the numbers here is my next action is actually mean and sum. Okay. You cannot perform the sum and the mean on top of the string elements, right? That is the reason I'm taking the numbers here. See, the max element is actually 84 here. Now after max, I'll just try to take the mean here. Okay. Mean is nothing but average. So average of all these values, it will try to display. Say 29.6. Okay, so sum also I can take it here. Okay, so it will try to give you the sum of all the values. See 148. All these are actions only. Okay, standard deviation, variance also you can find. All these are related to like data science actually. Oh, sorry, something is wrong. Yeah. Okay, so now I'm going to discuss about the um, reduce, aggregate, and fold. Okay, so let me first take the reduce. Okay, so first let's go to the documentation here and try to understand it theoretically. And later we move on to the practical part. So reduce. Yeah, this is the one. If you understand the reduce here, you'll understand the reduce by key in pair RDD easily. Okay. Huh. We have already seen this reduce operation in Python. What it does actually, cumulative sum of the elements, right? That is what we understood, right, in Python? Did we understand it or not in the Python? Did we discuss or not?
Yes, sir. Not remembering.
We discussed already reduce. In a higher order functions, I discussed. Okay,
Okay.
anyway. So reduce is the elements of the RDD using a specified commutative and associative binary operator. Currently reduces the partitions locally. Now what it does is, let me try to take some elements here. Okay, where is this one? Just a second. Ah, here only, right? Yeah. So what I will do is I'll just try to take the numbers, simple numbers here, so that it's easy for us to understand. 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8 I'm taking here. If you want, you can take 9 elements also, no problem here. Okay. So what I'll do is I'll just try to control the number of partitions here, or I'll take 2 here, or 3 also you can take it, no problem. Okay. Um, what reduce will take actually as an input? Function it will take as an input, and it will give like values and output. Local value it will try to display. Okay. Now what I will do is I'll just go here, reduce of reduce of. Since it is taking the function, I wanted to take the function lambda function here, lambda x comma y colon x plus y. This is what I'm taking here. I'll tell you why I'm taking only this one. My ultimate goal is actually to find out the sum of all these elements. Sum of all these elements. That is my goal. So for that, I'm just trying to take the plus operation here. Okay. So before that one, what I wanted to know or understand here is, I wanted to understand how many elements are there in each partition. What elements are there in each partition? Okay. So for that, RDD2 dot glom dot collect I'm taking here. Okay. Let me execute this one and see what is happening. See, 40. I have to take the print here because it is overwriting the output here. See, first it is printing 1, 2, 3, 4 into one partition, 5, 6, 7, 8, 9 into one partition. Okay. You know what happens here in the backend? Let me explain this one. So this is your master node. This is your master node. And let's consider we have two executors are there. Okay. So this executor is taking this partition, that is 1, 2, 3, 4. So inside it is taking actually 1, 2, 3, 4 values. Here, 5, 6, 7, 8, 9 values it is taking. Okay. You know what happens here? It will try to take the in any of the aggregation operations like reduce, fold, and aggregate operations. You know what will happen? First, initially, the local aggregation will happen. What do you mean by local aggregation? So the data is actually distributed across the executors. So at each executor level, local aggregation will happen. Now, what do you mean by local aggregation is 1 plus 2 plus 3 plus 4. Summation will happen. That will be, the sum will be maintained in this executor. And here also 5 plus 6 plus 7 plus 8 plus 9. So the local aggregation will happen and the output will be maintained here. Okay. Now, after that, whatever the output you're getting from this one, whatever the output you're getting from this one, both outputs will be collected at the master node, and the master node will try to aggregate the remaining values. I mean, the output values, so that you'll get the resultant value as 45 here. Are you getting my point? Okay. How it is going to see in the documentation also you understood, right? It is going to perform cumulative sum actually. What do you mean by cumulative sum? So when you write like this, one will be taken into this x. Okay, two will be taken into this y. Okay. First, what will happen? 1 plus 2 will happen first. 1 plus 2 output is 3. The accumulated value is 3. So now 3 will be taken into x in the next element, in the next iteration, I can say. Okay, 3 will be taken in the x, and second, already element 3 is there, right? That will be taken in the y. Accumulated value plus next element. Only first two elements it will try to take initially as for aggregation, and after that accumulated value will get added to the next element. That is the behavior of the reduce actually. Did you guys get it what I'm trying to say? Yes or no?
Yes, sir. Yes, sure.
Is it very
Then,
difficult to understand? Do you feel it is difficult?
then
Okay.
why we are using lambda there? Directly with reduce function, we can't achieve this.
No, we cannot do that one. See, the syntax also you try to understand here. Ah, where is this? Syntax also, see, reduce function is taking function as an input, right?
Okay.
Okay, that is the reason we are taking the function here.
Okay, we can
See,
use it.
okay, I'll discuss about that one also. Okay. See, every time you don't do only plus operation, right? You can do multiplication operation also, right?
Mm-mm. Mm.
You can do like a minus operation also, right?
Yeah, anything we can do.
Uh, anything we anything we can do it, right? So based on what you wanted to reduce the elements, that's what you have to have that flexibility, right? For that only it is taking actually lambda function as an input.
Mm.
Okay. So if I take 3 here, let's say I'm just trying to take 3 here, it will try to distribute it equally. What I'll do is I'll just take out the element 9 here. Okay, R4 I'll try to take here. That is also fine. Yeah, let me try
Again,
to.
equally distribute.
Uh, yeah, that's okay. Equally distributing it, right? Let me take 9 here in that case. Okay. Now let's see what is happening. Hmm. So first 1 plus 2 will happen at first partition level, at first executor level. 1 plus 3 actually, 1 plus 2 is actually 3. So 3 will be maintained here. So like that, at each and every partition level, local aggregation will happen. And after that, uh, uh, across the partitions, it will try to collect the values. From each partition, it will try to collect the values and it will try to finally sum the values actually. Okay. Now that is fine. That is fine. We are good with this one. Now, let me try to perform minus operation here and see what is the output you're going to get. Okay. Now, okay, let me not erase this one. Oh, so if I take minus here, what is your expected value here? What is your expected output here? Okay, now people will start thinking that okay, 1 minus 2 minus 1, 3 minus 4, again minus 1. Correct, right? Correct, right? Okay. And 5 minus 6 is minus of 5 minus 6 is minus 1 again. Okay. 7 of 7 minus 8 minus 1 minus 1 minus 9 minus 1 minus 9 minus 10, minus 10 or not?
I think it
Come on,
won't
guys.
perform that, right?
It will perform, right?
Uh, okay.
No, first it will take 7 into x, 8 into y, right? 7 minus 8 will be performed, right? 7 minus 8 is
Minus
minus 1.
1.
Minus of
Minus
next
10.
value is minus 9 only, right?
Minus 10. Yeah.
Minus 10 only we are getting. Okay. So minus 1 plus 1 got cancelled here. Minus of minus 1 plus 1. 1. Okay. Minus of minus 10 plus 10. Okay. What is the output you are expecting? 11. Let me execute this one and see what is happening here. 11. Yeah, see? 1 plus 10, 11 we are getting. Okay. Now let me tell you the caveats in this one. You're not supposed to use minus operation, guys. You know why? Okay. So you guys are thinking in a generic way here. Okay. The first two values will go to this partition, 1 comma 2. Second partition will go to second executor. That is the let's consider second partition is here somewhere here. Okay, it takes the values 3 comma 4. Okay, and next partition 5 comma 6. Next partition 7 comma 8 comma 9 is there. Okay, so you're thinking that okay, first one it is giving output 1 minus 2 minus 1, 3 minus 4 it is performing like that. You're thinking, right? What if you're getting Paula, can you stop scribbling on my screen, please? Okay, sorry. Huh. Partition 1, partition 2, partition 3, partition 4. Okay. Now 1 comma 2, 3 comma 4, 5 comma 6. Okay. 7 comma, sorry, 7 comma 8 comma 9. Okay. Now, what if this partition is giving output first to the master node? What will happen? 7 minus 8 is what? Minus 1. Minus 1 minus 9. What? Minus 10.
Yes.
Okay. Minus 10. Then consider this one is giving output next to the master node. Okay. So minus of 3 minus 4. Minus 1, huh? Minus 1 or not? Okay.
Yes.
Next, this one is giving output minus of minus 1. Okay. Again, minus of minus 1. Okay. If this is the case, actually, what is the output of the result? What is the result actually? Minus 10, minus
Plus
10,
1.
minus into minus plus,
Plus
plus 1,
1.
1, plus
Again.
1,
Again
plus
plus
1.
1.
Correct?
Minus
What
7.
is the output? Minus
7.
7. Now see, you're thinking that first partition is giving, I don't know, who is that? Naresh, please stop scribbling on my screen, please. Okay. So you're thinking that first partition is coming first, and second partition is coming next. Third partition is giving output next, and fourth partition. So since you're thinking that you got result as 11. What if? See, I cannot guarantee that which partition is going to give the output first. I cannot give any guarantee. See, in a cluster, actually, this is like all these partitions are actually partitions in a single node in my system, single node. But in a cluster, actually, the performance is not same across the like nodes. This may give the output first. This may give the output first. This may give the output first. Okay, so any executor can give the output first based on its configuration, based on its performance. I can say. In that case, the results are not consistent. Okay, so whatever the operation you're taking here, whatever the symbol you're taking here, plus, minus, into, whatever you're taking here, that symbol should satisfy actually this rule. What is this commutative and associative law? In our childhood days, like
Yes.
we studied, right? Commutative law and associative law.
Yes, sure, but not remember exactly.
Uh,
A
A
plus
plus
B
B
equals
plus
C
C
plus
equal to
D.
B plus C plus C.
Okay,
C plus
okay.
B plus C, right?
Mm.
That is the one. Okay. It should satisfy that commutative and the associative law. Then only we we have to use that symbol. Okay. Now which symbols actually satisfies that?
Plus symbol
And into also, right?
into multiplication.
Hmm. Plus and into satisfy that law. That is the reason why we have to take only in the functions plus and into symbols only, not the minus. Clear? Clear with the reduce?
Yeah.
If you want, I can bring up my notes as well. Somewhere I've written that. Control F, reduce. This is pair RDD, sorry. Reduce. Yeah. See, this is what I was telling. Executor 1, executor 2, executor 3. Language Python I'm taking it. Okay. Uh, Executor 1, executor 2. See, first time you're getting output as 16. If you take these values actually, 1 to 8. Next time, if you try to consider this one is giving output first, then in that case, you'll get minus 14. If you think that this one is giving, I mean, executor 2 is giving the output first, then in that case, you'll get the 15. Every time you're getting the different result. Different result.
Mm.
Okay, so that is the reason why the symbol has to satisfy actually. The symbol has to satisfy the associative and commutative law. This is what associative and commutative law. Associative law is nothing but A plus B plus C equal to A plus B plus C. It has to satisfy that. Our commutative law is nothing but A plus B equal to B plus C. A minus B equal to B minus A, na? 1 minus 2 equal to 2 minus 1, na?
Mhm.
No, right? That is the reason why minus we are not supposed to take. The documentation is saying that. I'm not saying that one. Okay. So that is about reduce. Okay. Do you want to understand anything else here about reduce?
In data perspective, can we use anyway this one reduce function? Only for
To
arithmetic calculations only, right?
arithmetic calculations only. That's it. See, generally, when data frames concept was not there, right? If at all, if you want to do like summation and all, we used to like do this one only, cumulative sum. Sum is also there, but for some operations, we have to use this one also.
Okay, sure.
Okay. Nowadays, we are not using it at all.
Yeah.
Definitely. Because like all data frames are there, quite similar to your SQL. No difference at all.
Okay.
Okay. Yeah, that is about the reduce. Uh, Next one is actually fold. Okay, this is also one of the transfer action, not transformation. Sorry, action. Okay. Now let fold is also does this say similar activity, guys? But I'll tell you the difference between the fold and reduce here. So fold also aggregates the elements for each partition level. Okay, and then results for all the partitions. And using a given associative function and the neutral zero value. Okay, first let me explain the syntax here. RDD dot fold of it takes two parameters actually. One is zero value, second one is a function. but your reduce actually takes only function as input. But here, fold actually two values it takes as an input. One is zero value, second one is function. Okay. Let's consider same example, whatever I've taken here. Okay. You know what happens here? Let me take the plus only here. Now, in place of reduce, I'll just take here fold. So when I try to execute directly this one, it will throw error because it is actually expecting actually one more input or parameter, I can say. So that I'm taking as zero here. Okay. So if I take zero, okay, what is that output you're going to get? Fold also like performs the aggregation only. It is folding the values. 1 plus 2, 3 plus 4, 5 plus 6, 7 plus 8 plus 9. It is folding the values. That's it. Now output you're getting same thing. Okay, you know what happened in the back end here? Uh, Now let me explain that. Let's say this is my first partition. This is my second partition. This is my third partition. This is my fourth partition. Okay. And 1 comma 2 at the first partition. 3 comma 4 at the second partition. 5 comma 6. 7 comma 8 comma 9. Now, you know what will happen here? So at the local, like with respect to this particular executor, what will happen here? What will happen here? Local aggregation will happen, right? First, local aggregation means directly 1 plus 2 will happen, huh? Because I'm taking here x plus y, right? Directly will it load like 1 into x and 2 into y, and it will add that value and it will hold that? No. You know what happened in the case of fold here? The initial value, whatever you're mentioning, right? That will be taken as a x actually. The zero will be loaded into x here. Okay. And y is nothing but your 1 here. The first value always will be loaded into y. Now 0 plus 1, 1. 1 plus 2, 2 3. In that way it will do. So this will be considered as a initial cumulative value. Even at each partition level, same thing will happen. Now here also 0 plus 3, 3, 3 plus 4, 7, 0 plus 5, 5, 5 plus 6, 11, 0 plus 7, 7, 7 plus 8, 15, 15 plus 9, 24. It will, 0 will be spread across all the partitions. And now after that, whatever the result you're getting here, right? So you'll get the result here 3, you'll get result here 7, you'll get result here 11, and you will get result here 24, right? Okay. Now all the uh, like output values will be collected at the master node. Again here also 0 plus 3 it will happen 3, 3 plus 7 will happen 10, 10 plus 11 will happen 10 plus 11 is 21, 21 plus 24 will happen here 45. Now output you got is 45 here. Understood? The difference between the reduce and the fold?
Yes. If you give 1 there instead of 0, the value will
Yeah, yeah.
get
I'm
changed
coming
right
to that only
completely.
now. Coming to that. Now, if I give 1 here, what is the output you are expecting?
That's tricky.
46.
Not
46,
46.
huh?
No, no, no. It's not a 46.
No,
I told you, try to understand it.
yeah,
See, this
See,
initial
at 1.
value is there at all the partitions, right? Now,
And
first,
again, the,
1
yeah,
plus 1, 2, 2 plus 2,
4,
four,
sorry,
1
plus
plus
1.
3, 4, 4 plus 4,
8,
8, 1 plus 5, 6, 6 plus 6,
12,
12. Okay,
25.
1 plus 7, 8, 8 plus 8, 16, 16 plus 9, 25.
Again starts 1 plus 4.
Again, 1 plus 4, 5, 5 plus 8,
8,
13, 13 plus 12, 25,
25,
25 plus 25, 50.
50.
Let me execute that one. Let me prove that.
So,
So check what is the output you're getting here. See 50. Clear?
It depends upon again executors as well, right? If we give
No,
5,
see,
again it will change it.
since it is a plus operation, whether first one is giving output, last one is giving output, irrespective of that one, in the plus operation, you'll get the same output, right?
Yeah, yeah. No, partitions I'm making. Instead of 4, if you make it 5 with the same numbers,
The result will change.
yeah, result will change.
Result will change. Yeah.
Yeah,
Good
that's what.
point. Good point. You brought up. Okay. If I give only two here, what is your output?
47, 48.
Yes. See here, what is happening here? 48. Two will get reduced, right? Because two partitions only, right?
Yeah, two partitions.
Hmm. So this is your output now.
Then what is the use of these things, Shiva?
Uh, you'll understand all these things in pair RDDs. Not now. In the pair RDDs, you'll understand it.
Okay.
Okay. Hmm. I'll let you know definitely. These are all like plain RDDs. It's not pair, it's a plain RDDs. So you don't see much use cases. Okay. Next one.
Okay.
Moving on. Sorry. Someone is saying something.
No, Shiva.
Nothing. Shiva, 1 comma 2, first one means the zero value 1, 1 plus 1 plus 2, 3, right?
Yeah.
And again 5 comma 6 something,
Yeah.
4 plus like that only, right?
Yes. This one will be there in this partition. This one will be there in this partition also. So 1 plus 1, 1 plus 1 plus 2 plus 3 plus 4. 1 plus 5 plus 6 plus 7 plus 8 plus 9.
Okay.
Again 1 plus the result from this one, result from this one.
For each partition, it will be added, add
Ah.
one.
Yes. Okay. Next one is fold is done. Aggregate. Aggregate also does the same operation, guys. Same operation. Okay. But the difference between fold and aggregate is here. Aggregate takes the zero value as one of the parameter. Okay. And aggregate takes two different functions here. Okay. One is sequential function and second one is the combined function. OP is nothing but operator, combined operator, sequential operator. Okay. So two different functions we can create here and you can use them here. Okay. It accepts two functions as parameters. Okay. Just a second. Yeah. Sorry, guys. So aggregate will take three parameters as input, guys. Okay. Zero value, sequential function, and the combined function. Okay. So sequential function, again, I'm taking x plus y. Combined function also, I'm taking x plus y here. Okay. Let's try to do the same activity and see what is happening here. Okay. And now what I'll do is I'll just try to take here. Where is this one? Yeah. So aggregate in place of fold, I'm just taking here aggregate. Here, zero value I'm taking as zero only here. Okay, so one more function I'm just taking as same, I'm just copy pasting here. Now in this case, what is happening? We need to understand, execute this one and see the output. You'll get for 45 only again. See, 45 we are getting. So what is happening here? What is happening here? Okay, so again, I'll draw the picture here. So first partition, second partition, third partition, fourth partition here. Okay, see here. Okay, 1 comma 2, 3 comma 4, 5 comma 6, 7 comma 8 comma 9. Consider 4 different partitions are there. Now what will happen, at at a local level, locally, what operation has to be performed, that we can control with this one. This one, sorry, first one. Locally, what operation you wanted to do between these values, that we can control using this function. Once this result is collected at a master node, what operation you wanted to perform, that you can control this one. If you want, you can take here multiplication also, no problem at all. That means at each executor level, what operation you wanted to perform, that you can control easily with the help of lambda function. At a at a master node level, what operation you wanted to perform, that also you can control with the help of. But in the case of fold, in the case of reduce, we did not have any control. But here we have more flexibility. We have more flexibility. Okay. So if I take 0 here and if I take multiplication here, what is their output actually? If I take initial value as 0, at a combined level, if I take this one multiplication, what is your output?
Everything 0.
0 only, right? Okay, let me execute this one. See, sorry, sorry. My bad. I have to take here multiplication. Now see the output here. 0. Am I proving or not here?
Hmm.
If I take 1 here, then you'll get multiplied value. Okay, first, what will happen? 1, 2, 3, 4, 2 partitions, right? 1 plus 2 plus 3 plus 4. What is that output you're going to get? I'm poor in maths, guys. Please help me. 10,
10.
10. And 5 plus 6 plus 7 plus 8 plus 9. Okay, 1 will get added, right? 11 you'll get the first value. 11 you'll get, right? Correct,
Yes.
Correct, 11 only. Now combine these values.
19, 27,
5 plus 6,
0,
11. 11 plus 7, 18.
38.
18 plus 8, 26. 26 plus 9, 35. 35 into 11. What is that value you're going to get? If I see 396 only, right? No, 396.
No,
There
actually, not
36.
30.
36.
5 plus 1, yeah.
Okay, 36 into, yeah, correct. 360 plus 36, yeah, 396, correct. Correct. 396 is the output.
Hmm.
Okay, so this is what I was telling you. See, if you understand the purpose of this particular one, you will understand it easily. Okay, moving on. So we are almost done, guys, with the actions part. Remaining things we don't use it much. Take order also if you want you can take, but we don't use it much actually because it orders the elements first and take the values from it. So we are not supposed to use this one on huge volume of data. So I'm ignoring this one for now. I mean, take ordered and take is nothing but take is randomly it will pick. Take ordered is it will order the data and pick the data. Okay. And one more last point is here. Wherever you see, even in the data frames also, save as. If you see some somewhere save as table. Okay. Mostly you will see save as table only. Okay. Mostly save as table wherever you see, that is nothing but an action. If you're writing the data to some target, that is nothing but an action. Save as is an action. See, this is old slide actually. I mean, when RDDs was there, we used to use all these things. Nowadays, no one is using all these things. No one. We are not using Hadoop at all, first of all. Of course, some of the companies are using, very rare, but most of the companies are using like Spark on. Most 90 to 95%. So we don't need to understand like these functions. So we have in data frames, actually, I'm going to discuss about the save as table concept. That one you need to understand it carefully. Okay, got it? Can we move on to the pair RDDs quickly?
Shiva, for each, okay, some,
For each, just for iteration purpose.
that's
Hmm. So if you want, I can give you that one also. For each action in RDD. Oh, it is given for each means like each action it is taking, I think. Okay, for each we need to combine actually. Sorry, I think I gave it like this. Okay, so for each, right? Apply the function each element. If at all, if you want to perform like some function on each element, then we can use this. Okay. If you want, I can take the example as well for this one. Similar to map only. Let me take this one. Let's see. Or let me go to the documentation here. Where is this for each? See, function it is taking as an input. Okay. Applies the function to all the elements of this RDD. If you want to like do square of all the numbers, right? Then we can use that for each function. Okay. So I will quickly take that. Where is this? Where is this? Where is this? Yeah, this is the one, right? RDD, I'm taking this one. Now RDD2 dot. Okay. Uh, Instead of print of x, what I'll take is x star 2 I'm taking. Sorry, x star star 2. Square I'm taking. Star star is nothing but a square, right? Star star is a this one, right?
yeah, space.
So if I take this one, RDD2 dot collect I'm taking here. Let me execute this one, see what is happening. So RDDs. Hey, why did we get here only 1, 2, 3, 4? What happened here? Why did we get output 1, 2, 3, 4, 7, 8, 9 only?
First line you given two.
Two partitions, okay, fine.
Mm.
I'm just dividing that into two partitions. RDD2 dot. Oh, sorry. Like,
Cap.
each capital we need to use. Hey, we don't have
Think you don't take.
for each actually capital E only, as far as you know.
Also, document can show after capital
Documentation, we can see that, yeah. For each is small only.
small and
Applies a function to all the elements. Yeah, that is what the function I'm taking here. They have taken the print function. I'm taking the lambda function with the square here. I don't know what is happening here. Let me try to multiply only with the 2 here. Oh, I think I'm taking the capital X here. No, I don't know why is it not working. Okay, I'll check that one. I need to check that actually. I never used this one directly. I'll check that and let you know in next class. Okay. Anyway, moving on. Next one is we are done with the basic transformations and the actions part. Next one is actually pair RDDs. So these are all pair RDDs, guys. Pair RDD transformations and pair RDD actions. This one also bit easy, not complex at all. Okay. Um, I'll try to start with this one today. Now first let me go on to my notes. So what is pair RDD, here? Let's say I'm just trying to take actually, uh, I'm just trying to take the data like this. Okay. So let's say Kalyan, Raj, Venkat, Sunil, Anil, Ravi, Kiran, and with something like that, I'm just trying to take it. So what it is generating the output here? Um, it is back and it is trying to divide that into um, two partitions, and it is displaying as it is the correct is displaying the output as is, right? Now, what I wanted to do is I wanted to convert this into pair RDD. So for that, what I will do is I'll just try to use this pair RDD. I'm generating a pair RDD here. Pair RDD is nothing but a key value pair, I can say. Okay. Pair RDD. Okay. Same thing, right? Okay. Now let me execute this one. So what I'm trying to do here is RDD1 dot map of lambda function I'm taking here from the names, each element it will take, it will try to create a pair with its length, length comma name I have to take. Each element it will try to iterate. You guys know the map functionality, right? Map actually takes each and every element from the collection and it will try to apply this function on top of it, right? So length of name is nothing but its length, string length, comma name element. So it is like creating a pair RDD. Pair RDD. Pair. Key value pair. So that is the reason why we have to call it as a pair RDD here. Key value pairs. The input itself is a key value pair actually. Okay. So here also we have similar kind of transformations and actions here. So we have flat map values, how we have in flat map in normal RDD set. In the same way, flat map values is there. Group by key. See, everywhere you try to understand by key, by key, by key is there, right? Because we have to perform the operation based on the key only. Okay. So we have here in the set, we have actually union, Cartesian, subtraction, all those things. Here we have actually similar kind of things, but join conditions are also there extra. Okay. So, okay, coming to actions part. So we have keys. If at all, if you want to display only keys, then we can use this one. If you want to have like only values, then we can have this one. Like how we have seen the count operation in the RDD side. Similarly here, count by key, count by value, count by value approximate. Okay. So count by approximate, distinct by key, like that. We have different actions are there. So we'll try to understand the important ones here, not all, because we don't use them much actually. Okay. So let me move on to the first one. Let me move on to the first one. That is okay. First I started with the actions, I guess. Okay. Um okay, so let me try to take it directly here. Or we can take this one also. Huh. So data equal to, this is the key value pair, Alice 85, Bob 92, Charlie 78, plus 90, Bob 88, like that we have. Okay. So I'm just trying to create a RDD on top of this data. So parallelize is going to create actually RDD and it takes this data as an input. Okay. So key pair RDD equal to pair RDD's dot keys. Dot keys is an action or transformation. keys is an action, right? We don't need to. Okay, let me check this one. Let me check this. Why did I use here collect there? Can't I use directly? 1 second, guys. I'm not sure why did I use that one here. No, it's not displaying. So that means it is a transformation only. It's not a action in that case. It's a transformation only. I don't know like why they have mentioned. I took this slide deck from this Spark website only. Okay, anyway, I'll change that one. Okay. So what I'm trying to say here is keys actually will give you output as only keys. You guys know what is keys. Consider this is a dictionary. Okay, LS is mapped to 85, Bob is mapped to 92, Charlie is mapped to 78, right? Consider this is a dictionary. The dictionary, we call this one as a key, right? So even in the dictionary also, when you say dictionary dot keys, what you used to get in Python? Only keys, right? Same thing here also. It is creating an RDD in the backend and I'm just collecting on top of it. That's it. Okay. Similarly, output is Alice, Bob, Charlie, Alice, Bob, like whatever the keys are there here. I'm just trying to get that one here. Okay. If I take values, now see values, what you're getting here. What is your expectation? Values means 85, 92, 78, whatever the values are there, that you're going to get it here as it is. Okay. So two are done here. Okay. I'll just shift this one to the up here. Okay.
Shiva,
Uh,
always the input will be key pair combinations
key
only.
pair combination only. Correct.
If we give single, what you will get an error?
You'll get you cannot give like that one, right? One single value and others are like key value pairs. You cannot give like that one, right?
No, no.
Key value pair means the the RDDs you're going to create on top of key value pairs.
Okay.
So that's why we are calling it as a pair RDD.
Always if you want to use pair RD, the data also should be in a key pair.
Correct. The input should be key value pair.
Okay.
Okay. Next one, keys are done, values are done. Next, map values. So I think I did not mention that one, but we need to understand about this one also. So how we have actually, sorry, right then, right. So how we have map in normal RDDs, right? In the same way here also map values is there. Okay. Let me take. You can take the same example here. The this one is like this. The syntax is like this. RDD dot map values of map anyway takes the function as an input, right? Okay. So it gives again an RDD in a tuple format actually. In a tuple format. Okay. So if I take this as an example, Alice Charlie example, if at all if you want to increase the salary of each person, salary or like marks or whatever you consider, then we can use this one actually. The function I'm creating a user defined function here. I'm just using that user defined function to the map values here. Okay. So let me take up the same example, whatever I've taken here. Okay. I'm just copy pasting, guys. I don't want to waste the time here. Okay. So what I'm taking here is same data set I'm taking here. So I'm just taking here the user defined function. User defined function takes score as an input or X also you can take it here, no problem. That returns, it will, whatever the value it is taking, it will just add 5 to that one. It will give return that value here. Okay. Now new pair RDD equal to pair RDD dot map values. Map value is similar to map. It will take each and every key value pair from the data and it will try to apply this function on top of that. Okay. It will simply, but is it going to add the 5 to the keys or values? That's what your question, right? The name itself is indicating that values, right? Map values, right? Now, is it going to add the 5 to the keys or values now?
Values.
Values. Okay, now you'll get the output as alias 90 increased by 5. Now see, Alice 90, Bob 97, Charlie 83, David 93. See, simply it is adding 5 to each and every value. That's it. Did you understand? Flat map is similar to RDD, normal RDDs only. This one also take actually function as an input, and it is going to create tuple. So see, previous case also it was actually creating a tuple or not. Now see, it is creating a tuples, indirectly. Key value pair indirectly it is in tuple format,
Hmm.
right?
Yes.
That is what I was telling you. So even flat map values also gives the same output actually. Let me take one example here. Okay. So let's say data I'm taking like this. Okay. I wanted to wrap it up actually. Now let's consider like this. Alice, apple, orange, banana I'm taking here. And Bob, grape I'm taking. Charlie, watermelon, pear. The fruits that they like actually that I've taken here. And I've created one uh, the user defined function, split and flatten. That is what I'm taking here. So split and flatten actually what it returns, it will take the value from this one and it will simply split it. So when you apply split on top of this string, what will happen? What will happen?
One letter will get.
Not one.
We
See,
will get one more row Shiva, for each
no, no,
space.
no, 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 no. Think, think,
Apply
think, think,
the
think and tell me. Think and tell me.
Alice
That is flat
created
and
the
that is
dot.
flat
No,
map.
not
You're thinking in the same way how we discussed in flat map, right? No. See, what I'm trying to do is flat map also take works in the same way, but here the function you try to understand here. Function is actually taking value or string as an input and it is applying on top of that one split operation. Okay. Flat map values. That means this one it will take values. This one will take as an input here and it will simply split it. When you apply split function on top of any string, what will happen? What split function does actually, first of all, tell me. Come on, guys. I told you this is very important. Split function.
It
with
will.
It creates an array, right? List, right?
Yeah.
yeah.
So if you don't mention anything here based on what it will
Space.
split, what is the delimiter by default it takes
Apple,
actually?
comma, orange, comma, banana. In the
Space.
list.
Space. So do we have space here between apple and orange banana?
Yes.
Exactly. So it is going to give alias, comma, array of this fruits. That's what you are getting. And on top of that one, key value. Okay, key is nothing but actually. Okay, let me execute this one. See what happens. Now see, because I'm using the for loop rate. That is the reason we are getting that one. So alias apple, you'll get actually okay. If you want to see that result directly here,
Shiva,
print of
value dot
result.
split.
Sorry.
No. Print value dot split. Okay.
See. Okay, I think.
Value dot split. Shiva.
Sorry, one second. Yeah, sorry. Yeah. Result dot collect, right? Sorry. One second. I'll give you this one, and after that, I'll try to explain that. Value dot split. No, not required, right?
Just
Not required, right? Because it is going to display like this, right? Alice apple, Alice orange, Alice banana, Bob grape, Charlie watermelon, Charlie pea, right? So on top of that one, I'm just trying to generate actually for loop. For loop will take key value pair. I mean, for loop, here I'm just trying to use two values here from the result dot collector. So that is the reason it is taking like giving like this. Okay, its behavior is like that actually. I think I did not take much examples. Yeah, that's okay. Okay, so that is about flat map values. And the next one is count by key. What count by key will do? Uh, the, just by using the like function name, you just try to tell me. Count by key. Count by key.
Based on keys, it will count how many.
So that key got repeated how many times that it will simply give that count actually. Okay, let me execute the same thing. Alias key, right? See here. Till now we understood the operations on top of values. Now by key, now it will try to directly look the key actually. Now Alice appeared 2 times because here and here. Bob appeared 2 times here, here and here. Charlie appeared only once here. That is the reason why we are getting output like this. Okay. So next one, count by value is also there, but count by value will not behave like that you are expecting. You know what will happen here? If I take this one here, count by value. Now see what is the output you are expecting. What is the value you are expecting? Let's say Charlie. Let's say Alice 85 will take here. Now tell me, based on that, what is that output you're expecting?
85 to all are
85,
111.
85,
2,
2, 92, 178, 2, 88, 2, right? 1, right?
1, 1.
But your
78.
answer is wrong actually here. You know, when you say count by value, back end what will happen? This entire thing it will consider as a value only,
Okay.
not the exact value in the key value pair. That is the behavior of that count by value function. I don't know what is the use case of this one, but I'm just letting you know that. Okay, see, Alice 85 twice it appeared because Alice, 85, Alice, 85 we got, right? So Bob 92 once, Charlie 78 only once, Bob 88 only once.
Still wondering why. Where will
So
you use
give
these things?
another value, Shiva, like Bob,
So for
comma 9.
for duplicates removal, right? Indirectly you can identify the duplicates, right? Duplicate key value pair, right?
Okay.
Okay. Sort by key. So if at all, if you want to sort the data based on some key, then you can use this one actually based on the keys. Here my keys are actually 3, 1, 2, 1. Okay, let me take this one. Otherwise, now see, parallels of data and sort by key I'm taking here. Okay, so like sorted RDD ascending order I'm just correcting here, and descending order descending order also I need to correct here. I'm just copying this one and trying to paste it here. Descending order TCN. Okay, now this one I'm just trying to correct it here and see how it is. See, simply I'm mentioning here sort by key of either ascending equal to false or ascending equal to true. So ascending equal to true, you don't need to mention. By default, that true is enabled here. Okay, if I execute this one, then see. See, ascending order that is displaying. One orange, one grape you'll get first. One orange, one grape, two banana, three apple, three mango. See, descending order also you can get it. Yeah, see, 3 apple, 3 mango, 3 banana. Okay. So like this, we can apply some of the transformations or actions on top of the pair RDDs also, guys. So there are like reduced by keys also there. Even here also we have reduced by key, fold by key, and aggregate by key is also there. Whatever we understood it in normal RDDs, right? It is exactly same. Exactly same. Okay. But this will be performed. Aggregate by key means the values will be the aggregation will happen on the values based on the key. Okay. So if you want, I can discuss this one, or if you want to explore this one, you guys can explore that. If you guys are okay. Or I can explain this one tomorrow also as well. That is also fine. Or let me explain one first, and later you guys can explore the other ones. First reduce by key I'm taking here. So this one as an example I'm taking here. Okay, this is the best example to understand it in easy way. Okay, because we are taking the similar kind of examples in RDDs as well, right? Okay, so SC dot parallels of, okay, let me take the data first, execute this one, and based on the output, we'll try to understand. See the output here. B, how many times we got here? B, 10 we got here, 20, 10 plus 20, 30, 30 plus 10, 40, 40 plus 30, 70. B 70 we got it or not? Okay. So A 100, A 10 plus 15, 25, 25 plus 30, 55, 55 plus 20, 75, 75 plus 25, 100. That is what we got here, 100. C 70 also same thing. See, at high level, I can talk like this, but internally, what happens, here, when you try to divide that into multiple partitions, let's say I'm dividing that into 3 partitions. So let's consider in the first partition, we have this data. Okay. A10, A15, B10, B20. So first 4 values. Okay. Next 4 values in partition 2, next 4 values in the partition 3. Okay. You know what happened here? So A comma, I told you right already, like in RDDs, what will happen? Accumulated values always it will try to take. See, reduce by key, what I'm taking is, I'm just trying to use this function here, x plus y. Then what will happen? A comma, first these values will get paid up here. So 10, 15. 10 comma 15, it is going to create a pace here. And after that, it will try to add those values. 10 plus 15, output you're going to get 25 here. See, local aggregation will happen first. So wherever that A is there locally, that it will try to create a pace and it will try to add up those values. And after that, across the partitions also, it will try to perform that aggregation again. That is what I'm trying to say here. So the output at the local at each partition level, A comma 25, B comma 30 you will get. A comma 30, sorry, C comma 30, A comma 50, B comma 10 you will get. Okay, here also same thing. Now all these values will be passed on to the master node. What master node will do is again A comma wherever A is there, 25 plus 50 plus 25 it will try to add up. So you'll get output as like this: A 100, B 70, C 70, like that. Did you get it? Okay. So similarly, fold by key also, aggregate by key also works same way. But the only difference is fold by key, it takes the initial value. See here, 0 it is taking. 0 comma, add function I've already taken here. So it will simply take the values and try to add it here. Same concept. Aggregate is little different here. Aggregate is also quite similar to RDDs only, but it takes 2 functions as inputs here. See function 1, function 2. Function 1 is again addition operation. Function 2 is also addition operation. You can take the lambda functions or you can use the different functions as well. Anything is okay. Okay. Yeah, so that is about pair RDDs. We are done with the RDDs part, guys. So tomorrow I'll start the data frames. Clear? Data frames are very easy. They are not that complex.
But Databricks, data frames are very helpful, right?
Huh. For Databricks, actually, the base language is like data frames. The root is actually, if you understand data frames clearly, then Databricks will become very easy. See, same coding only, nothing. We don't we'll just try to add some functionality on top of that one. That's it.
Okay, sure.
Okay.